We learned 4 properties of metals in our earlier video. Can you name them for me? Metallic luster, malleability, ductility, and that they are hard. These were the 4 properties, right? Can you think of some more properties of metals? Metal utensils are used for cooking, aren't they? Why do you think they're used for this purpose? Which energy do we need to cook food? Heat energy. Correct. We need heat energy to cook food, and metal utensils are good conductors of heat. They help transfer heat evenly through the entire surface and provide even heating. No doubt, most metals are known to be good conductors of heat. Do you know the 2 best conductors of heat? They are silver and copper. 2 other metals like lead and mercury are comparatively poor conductors of heat. Electric wires were also made up of metals, right? Why is that? It's because they are good conductors of electricity too. If we have a battery and a bulb connected in a circuit with a metal wire, you will see that the bulb will glow where the switch is closed. And because they are good conductors of electricity, they are coated with rubber-like material. This rubber-like material acts as an insulator which protects us from being electrocuted if we touch the wire by mistake. Do you know any other property of metals? What happens when we strike a metal on a hard surface? Like utensils banging against the sink. Can you hear a sound produced by metal? Yes, this is another property of metals. We can call metals as sonorous, meaning they produce sound when hit against a hard surface. No doubt, school bells, church bells, or the bells in a temple are made up of metals. If these are the characteristics of metals, what do you think will be the characteristics of non-metals? In simple words, just the opposite of metals. In a nutshell, non-metals like carbon, iodine, or sulfur do not have luster. They do not shine and are brittle in nature. What do we mean by brittle? They cannot be beaten into sheets or wires, as most of them turn into powder when hit by a hard substance. Non-metals can also be gases like oxygen, hydrogen, or solids like carbon, sulfur, etc. Do you know of any non-metal in the liquid state? Bromine is the only non-metal which is in the liquid state. Non-metals do not conduct heat or electricity, and they do not produce that sound when hit against a hard surface. This means that they do not have the property of sonority. So isn't it easy and simple to differentiate between metals and non-metals only on the basis of their physical properties? Wait. But mercury is a metal in liquid state at room temperature, and bromine is a non-metal in a liquid state at room temperature. How do we differentiate between the 2 based on physical properties? We can say that all metals are solids at room temperature except mercury, and all non-metals are either solid or gaseous except bromine. Well, this is not it. There are a few more exceptions that break the physical appearance norms of metals and non-metals. For example, most metals have high melting point, which means that they need a large amount of heat to melt. But look at the 2 metals gallium and cesium. They melt when you keep them on your palm. We must say then that these 2 metals have a very low melting point. Look at another exception in non-metals. Iodine, for example, is a non-metal, but it has a property of the metals. Can you point out which property I'm talking about? Correct, the luster. Iodine has shine or luster, which is technically the property of metals. Take another example, carbon, for instance. What is carbon? Is it a metal or non-metal? Yes, carbon is a non-metal, but look at diamond or graphite. They all come from carbon. They are known as allotropes. The different forms in which carbon can exist are called its allotropes. Let us look at the allotrope diamond of carbon. It is known as the hardest substance and has an extremely high melting point and boiling point. Aren't these the properties of metals? But it is surprising that diamond is an allotrope of carbon, which is non-metal. Diamond too is a non-metal which strongly exhibits the properties of metals. Now that we know of so many exceptions, do you think it's easy to differentiate between metals and non-metals based on their physical properties? I doubt that, but don't worry. There is another way out of this. It is to differentiate the two based on their chemical properties. How is that done? For that, you will have to watch our next lesson.